Let's go ahead and consider an inverse problem. In other words, where you're given your proportion and you have to work backwards to either find a data value or your mean. So here, let's take a look at chocolate bars. Because of the hazelnuts in there, we can't guarantee an exact weight of 8 ounces all the time. However, it ends up being normally distributed, and we know from manufacturing that the standard distribution, standard deviation is 0.2. Now, we want 98% of the bars to be at 8 ounces or above, because we only want 2% to be considered under 8 ounces or underweight. So we have 8 ounces right here. We only want 2% of your curve to be here. So where does your mean have to be positioned so that only 2% is smaller than 8? Well, to do that, we need to go ahead and use our idea of the z-score again. So if you take your z-score formula and solve it for mu, which is your mean, you would get this. This formula was also given to you in this form back towards the end of Chapter 3. Now, we know our x is 8. We know our standard deviation is 0.2, but we got to look for our z. So to look for our z, we're looking for 0.2 to be in the middle of our chart. So you look in the middle here until you find a 0.02. To find a 0.02 in the middle of your chart, you got to go ahead and you find it over here, and we get right here. This is as close as we can get to a 0.02. This is just slightly more than that. It's a z-score of a negative 2.0, then a 5. So that's our z that we need to use. So we take that and plug it in for our z right here. So we have our 8 minus our negative 0.025 times our standard deviation, and we get 8.41 ounces. So on average, our chocolate bar that says 8 ounces, we really get 0.4 of an ounce more almost all the time. Cool. If you like chocolate, that is. Now, there's other types of probability. There's empirical probability. Empirical probability is pretty much probability that's been determined based on past events. So looking at historical data, you can come up with empirical probability. Then there's theoretical probability. And there we end up using the ideas of math and symmetry to be able to figure out that the probability of rolling any one number on a 6-sided dice is 1/6. There's also personal probability. Might be, what's the chance you think there's life on Mars? And somebody might say there's a 30% chance. Well, in reality, the chance of, or that there's being life on Mars is either 0 or 100%. It's 0 if there is no life on Mars. It's 100% if there is life on Mars. But we will often conjure up some type of a probability in our mind of what we believe the chance of that occurring is. So let's go ahead and take a look at some of these here. The probability is 0.5 of getting a girl in the hospital. So what's that mean? Well, it really means that over a long period of time, there'll be an equal portion of boys and girls born at this hospital. Which one of these is not considered random? Well, the one here that's not considered random is that the student will get the correct answer after hours of studying. Because the more you study, you greatly increase your chance of getting it right. So therefore, it's not just a random phenomenon. Okay, here we're looking at this table. We want to know, is this table accurate? Well, if you add up all your probabilities, you know all your probabilities have to add up to 1. And in this case, when you add up these 4 numbers on the bottom, yes, you do get 1. And all these probabilities are between 0 and 1. And so we're going to say yes, they do represent that. Now, We want to know what's the probability of getting a 1 or a 2 for your girls. 1 or 2 girls, that would be these two here. So all you want to do is take this probability and add it onto this one here. And so when you add those two together, you get 3/4, which is a 0.75. This one here, you're looking at all the numbers ranging from 1 to 5. You want to know, where do I need to put this blue line so that 25% of your data will be here? Well, from 1 to 5, that's a total distance of 4. And this is a quarter. So we got to go a quarter of the way. A quarter of the way of 4 is 1 unit. So we got to go 1 unit to the right. Notice you're starting at 1 and you go your 1 unit over. That would then put us over at 2. We want to decide if these are discrete or continuous situations. Here you're looking at the number of sales through a drive-through. In that case, that is a discrete situation. You would actually be able to list out all the different possibilities. Could be 0 if it's a really bad day, 1, 2, 3, or so on. Might go up to be quite a high number, but you could still list them all. And if you can list them all, it's a discrete situation. Now, on the time to run a marathon, that's really a continuous situation because you can have a really accurate stopwatch or time measurement device and you're pretty much able to get any possible time and you're not able to list them all.